Here's Kate VIP with another something for you to tinker with, because you're done tinkering with all the other stuff, right? And you got nothing else to do. Hi. Topic here is speech processing. This Drake TR3 has pretty much everything but, and I want to add it. That's can be a fairly complicated design. The microphone amplifiers in that radio, TR3 and TR4 from the factory, were 5 kilohertz wide, which is horrible. Since the sideband filter is only about 2 kc wide, and my experiments proved that having too wide a signal coming in actually distorts the shape of the sideband filter. It doesn't work nearly as well, and they're useless frequencies. So how to find a simple way to add some kind of speech processing? Well, top graph, a graph of power versus time. SEC requires us to reckon power as peak envelope power, peak to peak. Those sharp spikes are voice peaks from plosive letters and breath and such. Those peaks are pretty much useless to speech. And there's no use in speech with a puff of air in the microphone that makes a spike. So take the peaks off, and don't clip them because that causes distortion, but roll them off. And that allows raising what's marked as average AVG up to the peak level for far more transmit power. That's one thing processing does. Those peaks are generally at very low frequency. Very important. Down here is a graph of power vertically versus frequency horizontal. The dashed shape might be the shape of a sideband filter. In the TR3, when I swept the mic input up to 5 kilohertz, the passband of the filter was poor. When I reduced the frequency down to 3 kilohertz, the passband of the filter became almost ideal and dead flat across the top, maximally flat. So I have limited the bandwidth of the mic amps from about 100 to about 1700 inside the filter passband. That doesn't do anything about the peaks at low frequency. There sit two old Autech audio filters. I had one of these with the Heathkit HW7 as a novice. I got another one, a QF1A, to go with it. Only need one for receive. That filter has peak, notch, low pass, high pass. In other words, it can trim off high or low frequencies. Notch frequency, notch, frequency select, all that jazz. The peak-to-peak voltages coming out of these rigs to the speaker or headphones is somewhere around a max of a couple of volts. On the AC857, I designed the CW keying adapter to take the side tone, strip the tone off, for a speaker out voltage range of 0.1 up to 2.6 volts peak to peak. That's reasonably close to what we might find on a microphone. Now on this TR3, the correct microphone input is 70 millivolts. That's very low compared to that. But if the microphone levels are such that the filter can pass them, then instead of using a filter between the headphone or speaker out and the speaker, use it between the microphone and the input to the transmitter. And that will allow taking off this extraneous nonsense up here, and will result in a cleaner transmitter. How to set that up? Listen in another receiver, put an oscilloscope on the output of the filter, drive it with a sweep generator as best, say some word or phrase that causes peaks to be generated, and maybe use the high pass to cut that out. And there's a fairly cheap, easy way to make a speech processing, KBYP.